Look at this elegant exponential equation. 9 to the power of x minus 6 to the power of x equals 4 to the power of x. The challenge here is that we have three distinct bases, 9, 6, and 4, which prevents us from easily combining terms using standard arithmetic. To crack this puzzle, we need to transform the equation into a form we recognize. The key strategy is to normalize the equation by dividing every single term by the smallest base term, which is 4 to the power of x. Watch as we distribute this division across the equation. On the right side, 4 to the power of x divided by itself simplifies instantly to just 1. On the left side, we now have two fractions, 9 to the power of x over 4 to the power of x minus 6 to the power of x over 4 to the power of x. By applying the laws of exponents, we can pull the exponent x out of the numerator and denominator, grouping the bases together. This gives us the fraction 9 over 4 raised to the power of x, minus the fraction 6 over 4 raised to the power of x. Now, observe the numbers inside the parentheses. The fraction 6 over 4 reduces to 3 over 2. The fraction 9 over 4 is even more interesting because 9 is 3 squared and 4 is 2 squared. This means 9 over 4 is the same as 3 over 2 all squared. Suddenly, a pattern emerges. If we rewrite our equation with these simplified bases, the first term becomes the quantity 3 over 2 squared raised to the power of x. By swapping the exponents, this is the same as 3 over 2 to the power of x all squared. This reveals a hidden quadratic structure. Let us define a new variable, u, to be equal to 3 over 2 to the power of x. When we substitute this into our equation, the first term becomes u squared and the second term becomes u. We are left with the polynomial u squared minus u equals 1. Rearranging this by subtracting 1 from both sides, we get u squared minus u minus 1 equals 0. Does this look familiar? This specific quadratic is related to the golden ratio. Using the quadratic formula to solve for u, we get 1 plus or minus the square root of 5 all divided by 2. However, recall that u represents an exponential function, 3 over 2 to the power of x. Since a positive base raised to any power must yield a positive result, we must discard the negative solution. This leaves us with u equals 1 plus the square root of 5 over 2, which is the famous golden ratio, often denoted as phi. To find the final value of x, we reverse our substitution. We set 3 over 2 to the power of x equal to the golden ratio. To isolate x, we take the logarithm of both sides with a base of 3 over 2, or 1.5. Thus, our final answer for x is the log base 1.5 of the golden ratio. If you enjoyed this explanation, hit subscribe and check out our other math videos.